In this presentation, we will be looking at data frame and plotting using the R programming language. We will be working with some of the data from Edwin Hubble's studies on the expansion of the universe. We start off this program by assigning two vector variables. The first is distance and the second is velocity, dist and vel. Notice dist equals c, open parenthesis, then a bunch of numbers separated by comma and close parenthesis. Remember, c is the concatenate function in R. It turns a bunch of separate numbers into numbers that sort of work as a unit, sort of a list of velocities in this case and a list of distances. So that's the first and the second line. The third line of code here is combining the distance and velocity vectors into what's called a data frame, and then we call that data frame Hubble. So we're going up a higher level here. So we started off with a bunch of values. We combine them into a vector. Then we can combine vectors into what's called a data frame. And so the vector is a bunch of values and play a similar role, and then a data frame is associated vectors that are related to something. So the velocity and the distances here are related to deep space objects studied by Hubble. What we see here is the result of copying and pasting the data on the previous slide into an R script. And then we added one more line of code, the single line 10 that just says Hubble, and that is going to spit out the results of the Hubble data frame into the console below. And so you see that Hubble consists of a combination of distance and velocity sort of data points with two properties defining the data point, and it shows the numbering of those. Here we are using R's plot method, and we have, in this case, 5 arguments. The first two are the most important. They are the data that we are plotting. So the first is the x's. So Hubble $dist are the distances that Hubble used in his model, and that is the first argument. Then there's a comma, and then the next argument is Hubble $vel for the velocity. So those are the data that's going to go on the y-axis in this case. Our third argument is labeled main, so that identifies it as the main title, and we're just saying Hubble's data. Comma to get to the next argument. X lab equals distance in megaparsecs is the x-axis label, and y lab is the y-axis label, velocities in kilometers per second. Make sure you match parentheses, so the plot has an open parenthesis, and that parenthesis is not closed down until 18. There were 5 things separated by 4 commas, and all of the words were enclosed in quotation marks. And here's the result of that plot, again over in the plot area. And so we see the distance is on the x-axis, the velocities are on the y-axis, and we have our x-axis and y-axis labels and our title. If you want to utilize this plot outside of R, then you can export the plot by going to the drop-down list next to export above the plot, and then choose the format in which you want to export. Do you want to export it as a PDF or some image file, or to put it on the clipboard so it could be pasted into another, say, a Word document? Here we see another way to achieve an XY scatter graph. It still uses plot, but instead of saying Hubble $distance, comma, Hubble $velocity, it puts the y first and then the x and puts a tilde between them. So now we are doing Hubble $velocity tilde. That's on a keyboard on the upper left, and you need to shift. And then Hubble $distance. And it achieves the same thing, it's just another notation. Next we are going to get a fit for this data. So again, We can call this a fit, we can call it a regression, we can call it a trend line, or we can call it a linear model. R is referring it to as a linear model and uses an LM function to achieve it. So we're using the LM method, and now we put inside the parentheses the y and the x data that we are getting the linear model of, and it uses that tilde notation, so it wants the y first, so it's LM open parenthesis Hubble $vel tilde Hubble $dist close parenthesis, and the results of the linear model are being assigned to a variable hub_fit in this case. After assigning the linear model to the variable hubFit, we can then ask for a summary, use the summary method, and have as its argument hubFit, and that will show us a bunch of results from fitting the data, from doing the regression, from creating the linear model. Again, just different words for the same thing. And so I've given a result from Excel for sake of comparison. So we can see that it has the best fit slope, and they agree, and the best fit intercept, and we also see down near the bottom in the summary the r² value. In the case when we're fitting to a straight line, that line is easily added to the plot using the method AB_line. So the code is AB_line open parenthesis hub_fit. That was the name of the linear model, close parenthesis. If this code runs and doesn't show any error messages down in the console, but you don't see the line, the most likely culprit is some XY confusion. So look back at your data and make sure you have your X's and Y's straight. You can get some descriptions and help on R's linear model methods by typing the code help open parenthesis LM close parenthesis, and then over in that same region where you see the plots, you will see some help documentation on the linear model functionality. So here we see the code for extracting the intercept from the linear model. Our linear model was called hub_fit. We are extracting one of the coefficients from that model, so hub_fit $coefficients. There are multiple coefficients, so it's sort of a vector, and we are using square brackets, but instead of putting a number in those square brackets, this one uses a name. So the name of the element that we want is parentheses intercept, and with a capital I. So this is most easily achieved by going down to the summary and copying it. It must be exactly right, so the best thing to do is just copy it. And so it was coefficients, square bracket, quotations, and then go down into the summary and copy parentheses intercept and paste it up there in your script. And while we're at it, coefficients is a hard word to spell. So when you type hub_fit $ and start to type coefficient, it will give you a hint. So sort of accept the hint. You know, use your mouse and accept the hint. Okay, so that was the hub_fit $ coefficient square bracket quote parentheses intercept close parenthesis close quote close square bracket. Now we also have the round and this other comma to close parentheses. That is rounding the coefficient. The coefficient, while you see it in the summary with only 2 decimal places after the point, really has many more places. And if you don't round it, you will see those places. I wanted a sort of rather succinct, I'm going to use it in the display of an equation, so I don't want too many decimal places hanging around, so I rounded it to 2 places. So previously we showed how to get the intercept coefficient. Now we add to that the slope coefficient. And so the named index there was Hubble $dist, and you found that down in the summary. Just go down to the summary, copy and paste it, and also round it to 2 decimal places. in line 57, you see us putting together the slope and the intercept into a display of the equation. So this paste method just takes several arguments and pastes them together. And so I have y equal, and then the slope, and then an x plus, and then intercept. And so they just get pasted together. And so, but that doesn't display the equation, that just makes the equation to display. The actual displaying of the equation is that text method you see in line 58. So text 0.5, comma, 800, comma, and then the fit underscore EQ, the fit equation that we just made, close parenthesis. Okay, so the first argument is a middle x value. The second argument is a middle y value of what we're going to display on the plot. And then finally, the third argument is what we are going to display. So the 0.5 is an x value. So look on the x-axis and see where 0.5 is, and you'll find that that's sort of roughly the middle of the display horizontally. 800, the second argument, see where 800 is on the y-axis, and that is sort of the middle of the displayed equation. And you have to understand what these arguments in that method do, or you will end up with your displayed equation not being displayed because you don't have, appropriate x and y values for your graph.